how many degrees of freedom does a rigid diatomic molecule have? So what is apparent to me as I'm doing this video now is I think I jumped ahead in my last one by already introducing the concept of degrees of freedom. Might explain why the answer on that slide it said dimensions instead of degrees of freedom. Degrees of freedom is kind of a subtle concept, and I think one way of defining it is a degree of freedom corresponds to a way that mechanical energy can express itself in a microscopic system. At least that's the best kind of definition I can come up with for it. But again, it has some subtleties to it. But in this case, what we've said is that whether monatomic or diatomic, a molecule can move in 3 dimensions. That represents 3 different ways the energy can express itself. So 3 degrees of freedom there. And then we've talked about how there you could imagine maybe 3 rotations, but the third one we said really wasn't viable as a degrees of freedom, because for whether you accepted the classical explanation for why energy couldn't express it that way, itself that way, or the quantum explanation for why it's impossible for there to be energy in this type of a rotation, that amounted to 2 degrees of freedom for a total of 5. So therefore the answer here is 5, 3 for linear motion, and 2 for rotation.